Today on Zine to the Dawn, we got the repair of two Chauvet Intimidator beam LED 350s, and these are moving head beam lights for a medium-sized venue. I'll be replacing the LED power supply in both these moving head lights and getting into why I'm doing that later on in the video. Let's get into the repair process. Let's get inside the base of the moving head light. There are a couple of screws to remove to get the base off, and I think there's a total of 4 on each side. I believe that's it. There's some on the bottom. These screws are always a joy. Go ahead, punch the work light. That'll solve all the problems. So here is the control logic side, and then on the other side will be the power input and the DMX port side. Get out of there. Okay, so now we get to compare these two up, and I've already got the power supplies ordered. Now, the power supply was physically damaged from the bottom, and it took out the photocoupler feedback section of the power supply. I tried to repair them, but it just wasn't going too well. Could have replaced every single semiconductor on the power supply, but for $17 and 1 week wait, get new ones from the wonderful company of Shenpeng. Wonderful service from that company. A+. Let's move over to the other one. So with the new power supply, the first thing I want to do is connect up the high side of the power supply, which is the AC input on this side. So I got 3 wires to work with. I got the live, neutral, and ground. So slide this thing in, get that side hooked up, and we'll go from there. So hook that up. And let's hook that side up. Live, neutral, extrude. Got it. So right now I'm just getting to the terminal blocks in there, and these screws need to be pulled all the way out. A lot of fun, because yeah, they're loops. Makes things so much easier for me, but overall more durable. I'm just picking up little bits of metal from everything. It's the last thing I want on our new power supply. Little bits of floaty metal. Get in your home. Time for neutral. Alright, well, that's in place. And we have that here. We should be getting 5 volts on the output of that. So let's go plug this in, see if it works. And the LED is not connected up, but the power supply for the controller is hooked up, so we're going to get motion on the moving head as well. We're going to hear those motors and stuff power up as well. And power, a little light coming off of there, that's a good sign. So let's see what we have for the voltage. I should have said we should be getting 5 volts. It's a 5 volt 18 amp power supply. They advertise these as 100-watt LEDs. Funny thing about their rating though is you got a power supply, you got wattage, which is a multiplication of volts and amps. So 18 and 5 equal 90. So you got only 90 watts going to the 100-watt LED. LEDs are about 33% efficient as far as optical output. So in reality, yeah, not a 100-watt LED. You're getting 90 watts driven at 30% efficiency. Let's check out the voltage. And we're getting 5 volts on the FM dial. Looks good. So now we're going to trace out the power supply and see, not the power supply, we're going to trace out the power supply output and the wires for the power output that go to the LED switch controller. Let's take a look at that board, and I can get into a little bit of what the damage on this moving head is and why. Okay. Oh, here's the other board of concern. Now, the person who has the ownership rights of these moving headlights put these on a different mount, and the mount wasn't compatible, so he decided that he was going to make his own mount on the bottom. And I'll tell you, the drill is mightier than the aluminum case of the moving headlight, and ended up drilling through the bottom. So you can see here on this part, one of the holes where the drill went in. Of course, on the other side is where the power supply was, and he drilled into the photocoupler feedback circuit. Very simple board to look at, not much going on here. Let's look at it and diagnose and see what's on the board, see if there's anything that could be wrong. And he said that the lights came on for a couple of seconds and then went off. So this board that actually controls whether the LEDs is on or off is probably operational. looks like a very simple board here. We have the temperature feedback, and we have the control and other feedback stuff. So main power, some feedback, probably dimming control or whatnot. And then we have here a couple of gate drive ICs, and looks like, I'm not sure what that is. And we have 4 MOSFETs. Now the MOSFETs and stuff like that actually look like they're good, and they're only switching 18 amps. And I'm betting that each one of these MOSFETs can easily handle it. So even if one of these MOSFETs is bad, there's nothing shorted out, none of the MOSFETs are bad. So I'm expecting this board to work just the way it's intended to, especially seeing that the LEDs came on for a second. So why did the LEDs come on for a second? I'm figuring with the damage done to the power supply, it was a matter of there was a first cycle that went through the power supply before it took out the optocoupler feedback circuit and filled up the tank capacitors on the power supply. So when the circuit did initiate and give power to the LEDs turn on, basically it drained the tank capacitors for those couple of seconds, and then that was all there was. So let's get this part hooked up. And the reason why I have this part like this and out for the time being is simply to verify and connect up all the wires that need to be connected to, verify against this moving head as well on the other side. Make sure I got all my ducks in a row as to where the wires go. So there's a couple of wires. Firstly, the main feedback wires, the main feed wires for the LED power, which is going to be probably a common positive, and then the negative that goes over to the MOSFET side. So firstly and foremostly, I want to identify which wire is the shortest wires, and that'll be probably our positive, which looks to be this guy. So let's verify and see if that's our positive on the other one. And I'm going to get in the way a little bit here. There you go. Let's see. Let's find the shortest wire, which is going to be the wire that runs across. So that wire that goes down over and to here. That might be a negative. Okay, our short wire is a negative. Well, that makes sense too. I guess I suppose if it's going to the negative side. Okay, short wire is negative, and the negative input goes, that's that side. Okay, let's do that. So I'm just going to replicate everything over here. It's a little bit of a long process. Sorry about that. I'd speed it up if I could, folks, but, you know, I can speed it up in editing if you so desire. Alright, and the one with the black is on positive. Well, that's not confusing at all. Okay. I didn't design it. Oh, we'll put the black on the positive. That's what it wants. Looks clear. Okay. Now we got the short wire input. The short wire input goes to that one, and the one that runs up to the moving headlight. Looks like it goes. Yeah. Kind of runs up. Okay. Weird power supply. I'm not going to argue with it though. Okay. Let's do that then. Okay. So back over to this guy. And we're gonna see where that wire goes. So that wire, the wire, oh, that side towards me goes up, and the wire that way goes over. Okay. So control wires on that side, which goes up, back over to here. Thick wire that goes up. That side. Part ajar. Okay, and fetch out the screws. Always something. You know what? Will these screws fit? We're gonna find out. Of course not. They're too small. Arglebird. Okay. Found some screws that'll hopefully work. Not gonna use those ones that have a painted coating on them. No sir. Okay, that one feeds up. I could be a DJ, but yeah, you get way more screws if you're a technician. Okay, very good. Now I got these little wires that are just for signal, feedback, temperature, the whole 9 yards. Let's figure out where all of these go. Oh, the 3-wire ones. Pretty simple, self-explanatory. So, put that one there. I know there's one that's not used as well. So, we'll figure that out. Well, where's the unused one? Uh-oh. 2, 3, oh no, there's not a unused one. Okay. Little mark. I should have marked these. Yeah, this is going to be the long part. I gotta go trace some wires. Okay, well that was easier than I thought. Trace those wires out. I think it's connected. Right. Well, we're about to find out if there's something that's still wrong with it real quick, aren't we? Let's plug it in. Literally, you see it here live, folks. Come on, light up. Hey, that's a good sign. So one light seems to be working the way it's supposed to. Well, that's good. Let's do the other one. On to the second moving head light, which is where a lot of the fun's going to come in. I'm going to try to also get some better view of what's going on. So what I'm going to do here is kind of get ready. There's a couple of parts on the bottom that I need to undo. One of the parts that I need to undo is the lower bracket board also, so I can remove them. So I'm just going to free up the components that I need to free up, check out, which will be the power supply and the LED driver. Not that screw, those screws. So, take these out. And the other two for the LED power supply. Alright, flip that back over. While I'm on this side, I may as well take out the screws holding in the terminals for the mains input side. So, I can freely move this around, yes, no. What screws have I taken out? Is there another one? Are there more? 1, 2, 3. Oh yeah, there's a third, that's right. I'll get that one out too. There we go. Ground, neutral, and live. Oh, with those out, free up those wires. Yeah. And move to the controller side. I'm going to also need to remove the front controller section as well. These two screws on the bottom. Yeah. Undo those screws. We can take a look at the damage sustained on those now. Check them out, make sure that they're good to do their job. Let's go ahead and mark those so you know where they go with 100% certainty this time. A little bit of blue, and we're going to put a little bit of black on the other one. I just took all the guesswork out of reconnecting those. Okay. Let's remove the LED power supply. That should all go real quick now. So here's the control board, and it's a pretty simple control board. I've got another one pulled from another power supply, or no, another moving head light, sorry. And got the X and Y drivers for the pan and tilt, input power supply, various power supply components as far as voltage regulating and stuff like that, and the outputs for the various moving heads and inputs and stuff like that. Took the main IC off. There's a problem with the IC. The dimming function output pin on that driver didn't work, so toast. It's kind of a custom program loaded into those. Can't do anything about that. Alright, so here's the power supply. Oof. And yeah, you'll see what happened. I don't know. Focus. Where's the phone? Focus. Hello. Do your job. There you go. I don't know if you can see it or not, but let's see. Yeah. I get in there. And we can see where the one transistor for the feedback blew up. And that's because on the bottom it was drilled into right through there, and it shorted out. So hopefully the other board is still good. Get your back up on the tripod. Okay, moving on, they got the LED controller, which should be a perfectly functioning and fine part. So we'll go ahead and remove that as well. Go ahead and color code those. Come on out. There's nothing holding you in. There you go. Alright, it's the same bit. Looks like a hole was drilled in there. Didn't go all the way through. Looks like it went into some of the pads though. Oh. Looks like there might be some damage on this after all. Go take a look. So we're gonna do the MOSFETs. And I'm betting that these are all good. Take that plate off. And, oh yeah, so right into the traces there. The tripod does not allow me to negotiate the touchscreen at the same time. Alright, so yeah, there's that damage on the other side, so I'm going to run jumper wires over those. That should fix that board up. Alright, let's do those jumper wire connections. I move that over. Hopefully that stays where it's supposed to. Let's see, make sure that all of the area is clean. High powered traces. Luckily it looks like those prevented anything from being majorly shorted out. Oh, that's all the same trace, isn't it? Well, that's nice. Doesn't even look like there really is any major repair to do. Well. Hope it didn't directly ground out to the case, because that would be bad. Might have saved those MOSFETs though. Let's run this traces anyway. High current traces are always good to have. Especially when you're pushing 18 amps, man. Sorry, wire. Get off you. Okay. Looks good. Let's go test those MOSFETs. See if there's any bad gates. See what we get. Let's see. Source. Gate. Looks good. Let's check those gates. Uh-huh. Low. 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 Really looks like we're good. Let's rock it out. See what it does. Love heatsink compound. Gets everywhere. Nice distinguishing white pastel color. It's delicious. Perfecto. Alright, let's make sure that the drains are not connected to the case. Looks good. Isolated incidents. Put that in. New power supply. Plus and the minus, the weirdly black positive wire and the white I want to be a neutral wire. I love the color difference between the old and the new power supply. Ain't that a little disturbing? Whatever. It's okay. Come here, you earth. Da, da. Oh, that looks softer. Spin ya around. Let's see. Get those connected up. And then we can give it a test. Where's the other big thing go? I lost it. There it is. Hiding up on the top. Okay. Main power's connected. Uh-huh. There's the thermal sensor. Ding. And then black and blue. Okay, looks like we got a second chance for a magic smoke release situation. Wired up. Let's test the hypothesis. One power cord. One power port. Putting power in. Getting no smoke. Light fired up a little bit. It's a good sign that it came on and went back off. If it didn't go back off, the MOSFETs would have been totaled. We can get blinded together or watch smoke happen together. One of those will happen very slow. Okay, perfect. Wow, that looks awfully dirty in there. Sounds like some gateway thinking. Maybe we should open that up and see what's inside of it. Alright, let's open up the top, spin over the yoke, and get to it. Now this is basically the same thing as a Q-spot, so it's going to have some similarities to the Q-spot and some differences to the Q-spot. I'm betting what we're going to find in here is going to be pretty straightforward. no focus assembly in the front, the trifocus, a dichroic color wheel, a moving global wheel, maybe a stationary global wheel as well, especially if they're not using the focus output as they would on the Q-Spot. So let's see what's inside of this, but I'm guessing it's going to be pretty straightforward, pretty simple, not really anything too complicated. I said these are for medium-sized venues, so they don't go real bonkers with what's inside. I think this is the bottom portion. Let's see. All right. Looks like we do have focus. So what do we have here now? See if we can actually get a good look inside. Gonna bring the camera down just a little bit. So yeah, pretty straightforward. It does look like it actually does have a focus. So we've got right here the dichroic color wheel, first in the optical assembly. Then we got the stationary global wheel. It doesn't look like it has a mechanical global wheel. That's interesting. It's a bunch of dot effects. And then it goes to the different sizes and then globals. Interesting. Not seen a dot effect before. I don't know if you can see that or not. Let's go in and take the camera with me. So, yeah. Focus. So there. Kind of, yeah, weird little dot effect. And then we get different spot sizes. So big and small. Smaller, the pin spot. And then star, that shape, little slit, and back onto there. Interesting. Not very well balanced either for a mover. Alright, back up to a regularly scheduled programming. Looks like this lens is held on, the Fresnel lens is held on by 4 screws. I'm going to undo this side of the plastic as well. God, the balance on this is really terrible. Once this covers off, we'll give it a little bit of a cleaning and get inside. Interesting. The silver and black screws are leading me to believe that somebody was in here before. I know there's a cleaning label on here from 2016, so come on. That's always the screws that get you. I don't know why they call these intimidators. I don't merit that. There's the other side, yeah. The LED, the focus assembly rate. No, not the focus assembly. Stationary focus lens, magnetic Hall effect pickup, dichroic color wheel, a magnetic pickup for that. Got the steppers. Looks like the stepper is for moving the trifocus apparatus. Looks like we got a blurring, kind of a frosted blurring optic, and underneath that, is that a focus assembly at all? No, maybe we don't have a focus. Oh, maybe we do. Yeah, we do. Okay, spin this around. I see it now. So we do have a focusing assembly right here. Let's see, is that focused? Oh, am I focused on focus? Yeah, this right here is the focus assembly that travels up and down on those rails. Which stepper is that connected to? What is it? Is it connected to a stepper? It's not. That's fixed? They fixed that? What? What? That is a fixed focus point. That's not on a stepper at all. Okay, so it doesn't have any focus. For shame. And this board right here is basically the control board that takes all the data from the controller and controls the steppers up here. So you got our various stepper drivers, stepper inputs and stuff like that. The polyfuse. Looks like a 5-volt regulator to control the logic chip. So both these are some kind of custom programmed ICs. I can't get over that fixed focus. That's terrible. Let's remove the Fresnel lens and clean that up. Use water and care. It's a plastic lens, so we're not going to use any alcohol or adhesives on that lens. It looks like there's already a little bit of warping on it. Got warm or something. That's comforting. So there you go, yeah. That's English for you. There we have the 100 watt LED being driven by the 90 watt power supply, being cut off by the dicros. So, and the 33% percent efficiency, 33 watts out optical, and for some of the colors maybe getting 15 watts out optical. And I'm talking a load of nonsense here, but you know, the big heat sink, how much wattage has to be going there. Okay. Does that just rotate off? No, it doesn't. Good. So, yep, the trifocus assembly, the stepper for moving the frosted piece in and out, and yeah, the motor for moving the trifocus assembly. Which one are you? Let's move. Yeah, there's a motor to move this back and forth. And then the lens is inside. It's a little bit dirty there too. We'll clean that all up. Not too much going on in here. So, yeah, kind of a boring light. I'm going to get it cleaned up, get it put back together, and it'll be good to go. Both moving and lights seem to be repaired, so let's plug them in. I got one set to slave, one set to master. Get in there. And power. Put off the lights too. Hey. I say that's a win. Cool. And as always, Stay tuned for more.